Assalamu alaikum. In today's session, we will start exercise 4.2a from IGCSE Extended Mathematics that is recommended by AQA examinations. Our topic is averages and spread. Before moving to the questions, we will discuss about average and range. As we already have seen the basic concept about the averages and range in our previous lecture, but I want to review. Average is the central tendency of the data, or we can also say that average is the value that represents the center of the data. There are different techniques that are suitable to find average, like mean, mode, and median. Mean is usually used for the consecutive data values. And how to find mean? We can add the values and divide by the total number of values to get the average. Similarly, mode is usually used for the repeated data values. And we actually pick the value that is most frequent for the mode. And median is basically the middle value, and this method is usually used for non-consecutive data values. And when we have outliers or there is a large spread in the data, like we can see the example that the smallest value is 2 and the largest value is 100. So there is a very large spread over here. So we will use the median, means we will pick the middle value of the data to write the median. In this example, odd number of values are given. So it's very easy to pick the median, means the middle value, from the odd number of values. But in the case of even number of values, let's suppose I add one more number over here, like 150. In this case, there will be two middle values. Look, the middle values are 15 and 40. So in this case, for the median, we will find the mean of two middle values. Like we will add two middle values and divide by 2 to get the median. And we will also discuss about the range, and range is basically a bit different from the average, but range tells us about the consistency of the data. It is the difference of the highest and the lowest value. Like when there will be small range, the data will be considered as more consistent. While on the other hand, if there is large range, the data will be considered as less consistent. We also discussed about the IQR in our previous class. And IQR basically is similar to the range, but here we don't see the extreme values. Here we find the difference of the middle value of the upper half and the middle value of the lower half. For example, if I take some values 1, 2, 3, 4, 5, 6, and 7. Here I have a middle value which is 4, and I can divide the data into two halves. It means the lower half and the upper half. So here is the upper half, and the middle value of the upper half is 6, which is usually called Q3. And the middle value of the lower half is 2, which we name as Q1. So the difference of Q3 and Q1 is called the IQR. For the large data sets, we find the lower quartile means Q1 and upper quartile means Q3 using these formulas. These formulas gives the place value or the position of the values of the lower quartile and upper quartile. So we will also do some questions for better understanding. Now we are going to start our questions. In question number 1, it says the number of bottles of milk delivered to 2 houses is shown in the table. We can observe the table, and in its A part, they want us to calculate the range of number 45 and number 47. So definitely for number 45, the range is the difference of the maximum and minimum value. The maximum value is 2 and minimum value is 0, so the range is 2. While for number 47, the range is again the difference of the maximum and minimum value. So here the range is 4. In B part, they want us to compare the range of two data sets. So for number 45, the range is 2, and for number 47, the range is 4. The range basically indicates the spread of the data. So we can clearly see that the deliveries to the house 47 have greater variation than house 45. This means that the milk deliveries to the house 47 fluctuate more than to the house 45. Now we will proceed to next question. In question number 2, the number of cars at each house on Ullswater Drive are given here. We have to complete the table. So we have to count that how many houses where there are 0 cars. So there is one house where there is 0 cars, and similarly there are 3 houses where only 1 car, and the frequency of 2 means 2 cars are in 4 houses, and 3 cars, the frequency of 3 cars will be 1, and the frequency of 4 cars is also 1. We can also write the tally marks here. It should be 1. Here it should be 3. Here it will be 4. And then 1 again, and then 1 again. Now in B part, they want us to calculate the mean, mod, and median. Number of cars for Ullswater Drive. So let's calculate the mean first. For the mean, first of all, I need to know the sum of cars. Like how many total cars are there? And also, we will divide by the frequency. The total frequency means the total number of houses contains these cars. So for the sum of number of cars, first of all, we will find the total cars over here. In total, there is 0 car. And here, in total, there are 3 cars because 3 times 1 is 3. And here, there are total 8 cars. And then again, 3 cars. And then again, 4 cars. So if we finally add this data, we get 18. It means there were total 18 cars over here. And similarly, if we add the frequency, so the total frequency will be, if you add these values, we will get 10. Now to find the mean, the sum of cars was 18, and we need to divide by the total frequency, that is 10. So the mean value will be 1.8. Now let's calculate the median. And for the median, we first need to observe the frequency. So if the frequency is even, here we have even frequency. So in case of even frequency, there will be 2 middle values. And for the position of 2 middle values, we need to divide the frequency by 2. That will be 10 divided by 2 means 5th position. At 5th position, there is a middle value, and the second middle value will be at 6th position. Now let's see that which 2 numbers exist at 5th and 6th position. At 1st position, 0 exists. Then at 2nd, 3rd, and 4th position, 1 exists. And at 5th and 6th positions, 2 is existing. So it means the middle 2 values will be 2. At 5th position, 2 is there, and at 6th position, again we get 2. So for the median of 2 middle values, we find the mean of 2 middle values. That would be 2. So the median is 2. Now the mod is the most frequent data. And definitely the frequency of 2 cars is maximum here. So the mod is also 2. Now further, if we read the question, it says the mean, mod, and median number of cars at each house on Ambleside Close are 0.7, mod is 0, and median is 1. In C part, it says use the mean, mod, and median to compare the number of cars on Ullswater Drive and Ambleside Close. So we can also write the mean of the above data, which is 1.8, and mod is 2, and median is also 2. So we can easily conclude that Ullswater Drive has more cars overall, because every measure means mean, mod, and median is higher for Ullswater Drive as compared to Ambleside Close. So it means that the houses in Ullswater Drive on comparatively more cars as compared to Ambleside Close. Now we will proceed to next question. In question number 3, the range of these numbers is 17. They already have given that the range is 17. So let's mention that. Find 2 possible values for the unknown number. So we have some numbers like 34, 40, 25, and this is the unknown number. Let's consider this number as x. So in the first case, we have to basically find the 2 possible numbers that can satisfy the condition that the range becomes 17. So first of all, let's take that x as the minimum number. Let's suppose that this x is the minimum number. So the range is always the difference of the maximum and minimum number. And if the range is 17 and maximum number from these numbers will be 40, and if x is the minimum number, then we can find the x by subtracting 17 from 40. Like I have just shifted x on this side towards left and this constant towards right, and this will be 23. So this is the first possible number that can satisfy the data. On the other hand, if I take the x as maximum value, like this is the second case where I'm going to consider x as maximum value. So I will put x here and then I will subtract the minimum value. So in this case, let's suppose the minimum value is 25. Definitely if the x is maximum value, then minimum value amongst these 4 numbers should be 25. So the range is still 17. So to find the x here means maximum value, I will simply solve this equation by adding 25 and 17, and I will get x as 42. So this is another possible number that can satisfy the data. Now let's proceed to next question. In question number 4, it says Monica has 5 numbered cards. One of the cards is numbered -2.6, and Monica's cards have a range 7.2, median is 3.5, and mod is 4.1. Write down the 5 numbers on Monica's cards. So basically we have to satisfy the conditions that the mod should be 4.1, median should be 3.5, and range should be 7.2. So let's define the positions where these 5 numbers can be written. So as median is 3.5, so we can directly write the median first of all here because it's the middle value, and that should be 3.5. The range should be 7.2 and the mod should be 4.1. So let's write down two values, like mod should be 4.1. So that's why I can fill these blanks with 4.1 and 4.1 that satisfy the another condition as the mod is 4.1. Now, if we talk about the range, and to satisfy this condition that the range should be 7.2, so the difference between the maximum and minimum value should be 7.2. I can write 7.2 here. After adjusting the mod 4.1, the maximum value becomes 4.1, and we have to basically figure out the minimum value. For that purpose, I can bring 4.1 here, like 7.2, take away 4.1, and on the right side, there will be negative minimum value. And if I subtract 4.1 from 7.2, I will get 3.1. And also I can give the negative sign to 3.1, and I can write that the minimum value can be negative 3.1. So from range, we have got the minimum value that I can write on the left extreme. I'm left with negative 2.6, that is more than negative 3.1. So I can put it over here. And now these numbers are satisfying our conditions. Please observe that the mod was 4.1, and so I put it 2 times, and data had to be arranged in ascending order, so I put the values accordingly. Now we will proceed to next question. In question number 5, it says write down 3 sets of 7 numbers that have a median 6, range 14, and interquartile range should be 5. So let me write down the set 1. By the way, I will write 2 sets, and I will leave set 3 for you so that you can also try. Let me write down set 1. As there are 7 numbers, so I am making 7 blanks here. To satisfy the condition, it says the median should be 6. So let me fill the middle place with 6. The middle place is here. That should be 6. And it says that the range should be 14. To satisfy this condition, I can write 2 values here. This can be 1 and this can be 15. Because the range is basically the difference of maximum and minimum value. So look that if I put 15 here and 1 here, and if I subtract these 2 values, I get 14. So this satisfies another condition. And the last condition says that interquartile range should be 5. Interquartile range is basically the difference of the middle value of upper half and the middle value of lower half. So if I divide the data into lower half and upper half, the middle value of upper half will exist over there, and middle value of the lower half will exist over here. And they want us to have the difference 5, means the difference of the middle value of upper half and middle value of the lower half should be 5. So let's suppose I take Q3 as 7 and Q1 as 2. Look, the difference of these 2 values is 5. So this is satisfying another condition. Now, by maintaining the ascending order, I can put these 2 remaining values. Like I can write 3 here and 7 there. So this is the first set that satisfies the condition. Now we need to write another set. So I will again make 7 blanks here. As the condition says that median should be 6. So first of all, I have put the median as 6. And range should be 14. So I have to take 2 extreme values where the difference should be 14. So let me take, this time I am taking this extreme value as 2 and this extreme value as 16. Because again, the difference will be 14 over here. Now to satisfy another condition that the difference of the middle values of the lower and upper halves should be 5, So this time I'm taking this value as 3 and this value as 8. So I will write the remaining two numbers by maintaining the ascending order, that it can be 4 and it can be 7. So I have made another set that satisfies the condition. I'm leaving this remaining part for you. Now we will proceed to next question. In question number 6, it says a set of 5 numbers satisfies these criteria. Range is 10, median is 8, and mod should be 6. Explain why the mean of the numbers must be between 8.8 and 10.4. So I have to actually make the blanks, 5 blanks, because there is a data containing 5 numbers, and the range should be 10. So first of all, I can put the median as 8, which is the middle value. Now to satisfy this condition that mod should be 6, so these 2 blanks should be filled with 6, because we have to maintain the ascending order as well as the another condition that mod should be 6. So I'm taking 6 for both of these blanks that satisfy the condition while maintaining the ascending order. Now the range should be 10. So the only possible maximum number that I can put here is 16, because by taking 16 here, the range means the difference of the maximum and minimum value becomes 10. Now we have to decide this remaining number. And this remaining number can be any number between 8 and 16, because any number between 8 and 16 satisfy the condition, means it maintains the ascending order. I'm taking 9 here. Now let's explain why the mean of numbers must be between 8.8 and 10.4. Basically, these numbers are fixed, means the first 3 numbers and the last number means 5th number is fixed. We cannot change these numbers, because by changing these numbers, we cannot satisfy our condition. But this number at 4th position can be varied. So at 4th position, there can be any number between 8 and 16. Now let's see how the mean changes by changing the number at 4th position. Let's take the minimum possible number, means 8.1 here, and find the mean. At 4th position, I'm taking this number as 8.1. Now let's find the mean. Mean is the sum of numbers divided by the total numbers. So there are 5 numbers in total, and let's find the sum of all numbers, like 6, 6, 8, 8.1, and 16. And that would be 44.1 divided by 5, and we get the number as 8.82. And this number is slightly bigger than 8.8. It means that the minimum possible number that I actually chose, like that should be greater than 8.1, gives us the mean 8.82, which is slightly bigger than 8.8. Now we can assume another possible number at 4th position that will be close to 16. So this time I'm taking a number as 15. Now definitely the mean will change, because this time the 4th position is 15. So 6 plus 6 plus 8 plus 15 plus 16 and divided by 5 means 51 divided by 5, and that gives 10.2. And 10.2 is slightly less than 10.4, which is the limit of the mean. So now if I conclude that why the mean of numbers must be between 8.8 and 10.4, it's because that I can only vary this number between 8 and 16. So eventually this can only vary the mean between 8.8 and 10.4. Now we can proceed to next question. In question number 7, the bar chart shows the test results for the class of 20 students. And we are given with a bar chart, and we have to calculate the mean, mod, and median, range, and interquartile range. So for this purpose, first we can make a small table where on x-axis there are test marks, while on y-axis there are number of students, means the frequency of the students who get particular marks. So it starts from 1. There was 0 student who got 1 mark, and there was 1 student who got 2 marks. Similarly, there were 3 students who got 3 marks. There were 4 students who got 4 marks. And again, there was no student who got 5 marks. And then there were 3 students who got 6 marks, and 3 students who got 7 marks, and 3 students who got 8 marks, and 3 students who got 9 marks. Now, after completing the table, we can find the mean by first finding the frequency and total number of marks. So if I write down the total marks here, 1 times 0 is 0, 2 times 1 is 2, 3 times 3 is 9, then 16, then 0, then 18, then 21, then 24, and 27. Now, for the total frequency, I can add the number of students here. So if you add the frequencies, we get 20. And if we add the total marks, we get 117. Now let's divide 117 by 20. Now to find the mean, we can divide 117 by 20 and we get 5.85. It means on average, students got 5.85 marks. But when we calculate the mod, which is the most frequent number, so the highest frequency is of 4 marks, means most of the students got 4 marks. So the mod is 4. While if we talk about the median, median is the middle value. So to find the median, we first observe the frequency. If the frequency is even, then there will be 2 middle values. And for those 2 middle values, first we need to find the position of middle values. So for the position of middle values, we need to divide the frequency by 2. This is actually valid for even frequency. For the odd frequency, first we add 1 in frequency and then divide by 2 to get the middle value. But when we have even frequency, we just need to divide by 2 and we get the middle value, means 20 divided by 2 is 10. So at 10th position, the first middle value exists, and then 11th position, there will be second middle value. By the way, for the 10th and 11th position, we can write the tally marks here, and there will be 1 over there, and then 3, then 4, then 0, then 3 again, 3 again, 3, and again there will be 3 tally marks. So to find the 10th and 11th position, we need to start counting. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then 11. So at 10th and 11th position, we have 6. So it means the median will be the mean of 2 middle values, and both middle values are 6. So we can divide the sum of 2 middle values by 2 to get the mean of 2 middle values, and that will be the median, means 6. So if we see the average through median, it means on average 6 marks. Most of the students got 6 marks. Now we need to find the range, and range is the difference of maximum and minimum value here. So the maximum marks was 9 and minimum marks are 2. So the difference is 7. It means the range is 7. Now I have compressed the data to create a space here. And the next thing is interquartile range. Interquartile range is the difference of the middle value of upper half and lower half. So let's find the position of the middle value of upper half and lower half. For that purpose, we need to find the upper quartile. So for the position of upper quartile, we will use this formula, that is 3/4 times n plus 1. N represents the total frequency, which is 20. So let's find the position of, so this gives us the position of the value. So if n is 20, means 3/4 times 21. And this will be the position of the value. So if you calculate it, we get 15.75. Means this value will be at 15th or 16th position. So let's see. So we have got the position of the value. Let's see what does exist at this value. So if we start counting from the beginning, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15, 16, and 17. So at 15th and 16th position, 8 exists. It means this value, the value of Q3 will be 8. Now for lower quartile, we can again use the formula for the position of the value, and that will be 1/4 of n plus 1 value. So here n is 20 again, so 1/4 of 21 will give us the position of the value, and that will be 5.25. So let's see what is the value at this position. So again, we need to count. So we need to count from here. So 1, 2, 3, 4, and 5 and 6. So at 5th and 6th position, 4 exists. So it means the value of Q1 is 4. Now to find the IQR, we need to just subtract Q1 from Q3, that is 4. So this is how we find the IQR. Now, if we see B part, if a new student joined the class and got a mark of 10, how would this affect your answer to part A? So we need to carefully observe here that when we add one more student here who got 10 marks, this will definitely change the total marks. So if the total marks are being changed and the frequency is also changing to 21, so this will definitely change the mean. This time the sum of the marks will become 127 because 10 marks is being added, and this will become 21. So definitely by changing these two values, we get different mean. But if we talk about mod will not be changed because the most frequent data will remain same. While on the other hand, let's see that if the middle value is changing or not. Like if the frequency becomes 21, for the position of the middle value, we add 1 in it and then divide by 2. So it becomes 22 divided by 2, that becomes 11. It means the middle value will exist at 11th position. And at 11th position, we get 6. It means the median does not change, even if we add one more student. So mod is not changing, median is also not changing by disturbing the total number of students, but mean is changing. Now let's talk about range. Range is the difference of the maximum and minimum value, and when the maximum value becomes 10, so definitely the range will be changed. Means the range will become 10 minus 2, that will be 8. Similarly, if we talk about upper quartile and lower quartile, we need to do proper working, and we need to see that do we get different Q3 and Q1, or we get the same values. It depends, but we need to do proper calculations. We just need to change the n to 21. So in total, n plus 1 becomes 22 over there. So we need to find 3/4 of 22, and we will see that what do we get as the upper quartile. Similarly, we need to change n as 21, means we need to find 1/4 of 22. And we need to see that do we get a different Q1 or the same Q1. And then we can conclude that IQR is changing or not. So I did not do the proper calculations for B part here, but as I have completely discussed here, you can try it by your own. Now we will proceed to next question. In question number 8, it says there are 9 passengers on a bus. The mean age of the passengers is 44 years old. Let's write down the formula for the mean. We know that the mean is the sum of numbers divided by the total numbers. Or we can sometimes write here the frequency, the total frequency. So according to their first statement, where they are saying that there are total 9 passengers and the mean of the passengers is 44 years old, like the mean age of the passengers is 44 years old. So we can write here 44 and the total number was 9 because there were total 9 passengers. So from this data, we can easily find the sum of their ages. So let's see the next statement. It says that Sosen gets on the bus, who is 14 years old. Find the new mean age of the passengers on the bus. So let's make another equation that satisfies this next condition. Definitely the mean will change when there will be one more passenger added in the previous sum, and the age of the passenger is 14 years old. And now the total number of passengers will become 10. So to find the mean, first we need to find this sum, means the sum of the ages of previous scenario, or we can say the sum of the ages of 9 passengers. So we can easily find the sum of the ages of 9 passengers by multiplying 9 with 44. And we get this, and that would be 396. It means the sum of the ages of 9 passengers is 396 years. Now we can just substitute 396 at this place, because here the sum of numbers represent the sum of the ages of 9 passengers. And we need to find a new mean after addition of one more passenger who has age 14 years old. So we need to find the new mean. We can substitute the sum of the ages of the 9 passengers, which we got 396. So by adding one more passenger who is 14 years old, we can divide by 10. And that will be 410 divided by 10. So we will get the mean as 41. So look at how the mean is changed by addition of one more passenger. Now let's proceed to next question. In question number 9, it says Ruben counted the raisins in 21 boxes. The mean number of raisins per box was 14.1. So Ruben records the information for 20 of the boxes in the table. So it says that find the number of raisins in the last box. Means we know the number of raisins in first 20 boxes, but we don't know the number of raisins in the last box. So to find the number of raisins in the last box, we need to do some changings in this table. Means first we will find the total number of raisins in 5 boxes, then in 8 boxes, and then in 7 boxes. Because in 5 boxes, each box contains 13 raisins, and similarly, in 8 boxes, each box contains 14 raisins, and in 7 boxes, each box contains 15 raisins. So let's do some changings over there. First, we need to update the table. It says number of raisins versus the number of boxes. And I will add one more column that will contain the total number of raisins. So there are 5 boxes in which each box contains 13 raisins, and there are 8 boxes in which each box contains 14 raisins, and similarly there are 7 boxes where each box contains 15 raisins. So to get the total raisins of 5 boxes, we times 5 and 13, we get 65. So 5 times 13 is 65, and similarly 8 times 14 is 112, and 7 times 15 is 105. By the way, there is one more box over there where we don't know the number of raisins. So let's assume that number of raisins in the last box are x. There is one last box over there where we have x raisins, because we don't know the number of raisins and we have to find that. So in total, there will be x raisins over here, and we can also write x there, because x times 1 is x. Now, to find the mean, to apply the formula of the mean, we need to find the total frequency. The total frequency is 21. We already know there are total 21 boxes. And similarly, the total number of raisins are, if we add these numbers, we get 65 plus, by the way, there was 112 over there. So now if we add these numbers, we get 282 plus x. It means the sum of raisins will be 282 plus x, and x is the number of raisins we don't know and we have to find it. So let's apply the formula of the mean, which says the sum of the raisins divided by the total number of boxes. So the mean is already given, which is 14.1, and we know the number of boxes is 21, and the sum of the raisins will be 282 plus x. To find x, we need to simply solve this equation. So let's multiply 21 with 14.1, and then on the right side we get 282 plus x. So if we multiply 14.1 and 21, we get 296.1 equals 282 plus x. Now we just need to subtract 282 from 296.1, and that will be 14.1. So x represents the number of raisins. Since the number of raisins must be an integer, and assuming the mean is rounded to 1 dp, so the number of raisins in the last box will be 15. So we will assume x as integer. So let's assume x as 15. Means there will be 15 raisins in the last box, where the mean will become 14.1 if we round off that number. So let's proceed to next question. In question number 10, it says the mean mark in statistics test for a class was 84%. There are 32 students in the class, 12 of whom are girls. The mean mark in the test for the girls was 93%. Work out the mean mark in the statistics test for the boys. So first of all, we need to represent the first statement in mathematical form. It says that the mean of the test mark was 84%. Means the mean should be the sum of the students divided by the total number of students. By the way, here it will be the sum of the students' marks. So we know that there are total 32 students, and the mean of the statistics test is like as a whole, like the combined mean of 32 students is 84%. So we can write 84% here, and also we can represent the total number of students as 32. And the sum of the students' marks is unknown. We don't know the sum of the students' marks. So let's find the sum of the students' marks. We can multiply 32 with 84%, that is 0.84, and we get 26.88. This is the sum of the students' marks. Now let's read the other statement. It says that the mean mark in the test for the girls was 93%. Means we can also represent this information here in terms of the equation of mean, that the mean of the marks of girls is 93%, means the sum of the marks of girls divided by the total number of girls can be represented here. And mean is 93%, means 0.93, and we know that the total number of girls are 12. So let's find the marks of the sum of marks of girls, and that will be 12 times 0.93. So we will get the marks of girls, and that would be 11.16. So we have got the sum of marks of girls, which is 11.16, and the sum of marks of total students, which is 26.88. Now we can easily find the sum of marks of boys. So marks of boys will be definitely equal to the sum of marks of total students, take away the sum of marks of girls. So we can easily subtract 11.16 from 26.88, and that will be 15.72. So now we have got the sum of marks of boys, which is 15.72. Now let's conclude our solution, that after finding the marks of boys, we can easily find the mean of the marks of boys. That will be the sum of marks of boys divided by the total number of boys. So we have to find the mean, and sum of marks of boys is just found, which is 15.72. And out of 32 students, if 12 are girls, means 20 are boys. So let's represent the total boys as 20. So to find the mean, we can divide the sum of boys' marks by 20, and we get 0.786. To represent in percentage, we can times with 100, so we will get 78.6%. So this is the final answer of the question, that they were asking about the mean marks of the boys in statistics test. So we have got 78.6%. So this was all for today's class. Thank you.